Hello, fellow problem solvers. So today we're going to be talking about how to get better at algebra for the International Math Olympiad. Now, this has been a video that's been very well requested, and now I've finally come up with some ideas as to what you should prepare for, what you need to know, the techniques and theory and whatnot. So now let's begin. We'll start with the basics and move our way up to the top. So the basics start off with some basic algebraic manipulations. You need to know how to add fractions together. And after that, you need to understand like the basics of inequalities. That if a is greater than or equal to b is greater than or and b is greater than or equal to c, then you have a is greater than or equal to c. And also you can add inequalities together. If a is greater than or equal to b and c is greater than or equal to d, then a plus c is greater than or equal to b plus d. Stuff like that. That a square is always positive, and the definitions of absolute values, maybe even of complex numbers, if that's something that can come up in some competitions of yours. But even it's just good to know, because that can open up the space for you to learn more deeply things about polynomials or even geometry that involves complex numbers. So that is sort of the introductory level. And then you need to learn about induction. Actually, before you learn about induction, you need to also understand quadratic equation, what it is, what its solutions are, Vieta's rules. And these are things you learn about in school. And after you've done the quadratic, then we move on to induction, which is a big thing. You know, it's a next level of thinking that you use often in all fields, but I think it's also very much used in algebra. Say, how do you prove that 2 to the power of n is it greater than or less than n factorial? How do you go about doing that? Right? It's less than n factorial. Or say, is 2 to the n or n squared, which one is greater? Right? How are you going to prove these things? And induction is the answer to that. Then after induction, you also want to, after you've done the basics of inequalities, you also want to learn about some more advanced inequalities like, we start with AMGM, then we learn Cauchy and Schur's inequality. And after that, you can really solve a big portion, like 80% of all math problems in inequalities with those, where you just know those three, the AMGM, Schur, and Cauchy. But then you can learn some other things like the rearrangement inequality, Muirhead, I don't know the exact name, Holder's inequalities, like a bit more of a generalization of Cauchy-Schwarz. And there are many other things that you can learn, build up this theory. But really, if you know the basics here, and I'm calling the basics AMGM, or AMGM and the quadratic, the power mean, maybe the generalized is a bit advanced, and it's only been used, I believe, once at the IMO 2020 problem number 2. And after that, you also have Cauchy and Schur. Like, these are the basic tools, and you build up from there. Then after that, you also want to dive deeper into polynomials. Yes, you have Bezout's rule, like if you have a 0, then you know you can factor the polynomial, but then there's so much more to learn with polynomials, and I'll be making a video series on an introduction to polynomials, so you can definitely check that out if you want to learn more about them. After polynomials, there's also functional equations. Like, these things all go hand in hand, right? You learn a bit of polynomials, then you do some functional equations. And a subset of functional equations is sequences, which you can also think of functions from the positive integers or the non-negative integers or the natural numbers to some other subset, right? Like real numbers, integers again, positives, but that's really what sequences are. And these are beasts of their own. Sometimes these are like, these are functions from n to r. That's a way that you can also look at sequences. That's a thing to know. We've covered Vieta's rules. And with that, am I missing anything? And the final thing that I actually forgot is how to do recursive equations, how to solve them. There's also things with equations like arithmetic and geometric series. And maybe, though this is not by any means necessary, at least not now at the making of this video, wasn't necessarily the IMO when I came to the IMO, but maybe just like the basics of understanding of not calculus per se, though that can be helpful, but maybe, and this is really, I want to stress this very much so for those of you that are just about, I want to learn so much theory. You don't really need that much. If you just learn the basics of induction, source and functional equations, the three basic inequalities, and with that you solve a lot of problems, you can pretty much solve 90% of problems if you get very, very good at that. Even problems at the IMO. So keep that in mind. It's a lot more about thinking, and of course the basics of polynomials. And with that, like recursive equations can also be useful just to know that it's a rule of technique. Now there are more advanced things that I frankly don't think are very necessary for the IMO, but you can always learn them, though. I mean, things like generating functions. I frankly don't know generating functions. And I've done pretty decently at the IMO. 3 bronze medals, not a bad result. And with that, it says like, these are the bare basics. And with that, get problem solving. Like that's really the end goal that you want to do because you're preparing for an exam. I always say problem solve, because you're preparing for a situation where you're going to solve problems, not a situation where you're going to regurgitate theory. Theory is a helper for you to solve problems. And this finishes up our discussion, and as always, thanks for problem solving.